Welcome everyone. I know that people are still filing into the webinar, but I think that we need to get started with the day because we have a lot to cover today and a very short amount of time to do it. Thank you everyone for joining us today. My name is Jeff Chapman. I'm with the marketing team at InOrbit. You have registered and showed up for the Mission InOrbit webinar today. Thank you very much. We're going to be talking all about InOrbit missions, what that means, define, execute, analyze. 3 words you're going to hear a lot of today. But I have just some quick housekeeping to go over before I turn you over to today's hosts for the webinar. So briefly, this webinar will be 30 minutes long. We have a very short amount of time, a lot to cover, like I said. Second, this webinar is being recorded. So if any of your colleagues might be interested in this or anyone you know didn't get a chance to attend, we will be sending out a VOD of this webinar after the fact, and you can feel free to share it with anyone you like. And then finally, questions. Usually we do take questions. We're going to absolutely try to take your Q&A at the end of today's webinar, time permitting. I'm not sure we will have time for that though, but please send any questions you have into the chat and we will happily capture those. And if we can address them, we will. If we can't, during this webinar, we'll certainly follow up with anyone who has any questions after the fact. So with that, I'm going to bring on our host right away. Please join me in welcoming your host for today, the InOrbit CEO and co-founder Florian Pestoni, and InOrbit's VP of Technology and Operations, John Simmons. Gentlemen.
Thanks everyone so much for being here today. As Jeff said, we have a lot to cover. We're on a mission, unintended, to basically enable robots to become more widespread in the world. Let me share a few slides, and then we'll get into the meat of the discussion very quickly. So if any of you are new to InOrbit, we do something we call RobOps at scale. So if you're familiar with the concept of DevOps, RobOps will feel very familiar. It basically stands for robot operations. And we're really, our goal is, the at scale part is, how do we help companies scale their fleet of robots? How do, both from you're making robots and you're trying to get more robots out in the world, as well as you're using robots as part of your operations. So our core mission is to accelerate the adoption of smart robots. And these are robots that use sensors and AI to navigate around the world. So because the world is chaotic and messy, that brings a lot of complexity. But we do believe that robots, smart robots will become as widespread as cars or power tools are today. And this is happening across lots of industries, including industries that have had relatively low levels of automation. So for example, we've seen robots in manufacturing for decades, but now we see more flexible manufacturing. Or in logistics, where you've had machines like forklifts, now we're seeing much more adoption of robotics, autonomous robots that can move materials around or perform inventory checks or even clean the floor, right? And then what's interesting is this is spreading to other areas like retail, agriculture, hospitals, hotels. So really a lot of these industries that have had a heavy dependence on manual labor, now the labor is getting a bit of help from the robots. And I mentioned this idea of RobOps just to spend a couple of minutes on it. It's really this cycle that includes both the robotics part, the design and development of robots, as well as the operations side. So once the robots go out into the real world, you can't just leave them alone. And this has 2 perspectives. From the point of view of a robot developer, it really starts on the left side, from the point of view of an end user, it's really about the operations. But these, all these areas have to be working together. So we like to talk about the 4 O's of robot operations, especially on the ops side. And it all starts with observability, knowing what's going on. If you don't have data, you can't make things better. On the next step is the operational aspects. So robots need to be managed, monitored, need help every now and then. So this is an ongoing effort. And then we get into the fun part of orchestrating the robots with enterprise systems, with other robots, with equipment that you may find in the site. And ultimately, the goal is, how can I make this run better and better and better? So we like to talk about maximizing the potential of every robot. So this is what happens when you don't orchestrate. So as you add more robots, things get more complicated, and then people, eventually are not happy. So I like to say that orchestration prevents frustration. So maybe just to make this a little bit more tangible, let's look at the logistics space. So you have a warehouse, you have all of these different robots that are being developed for different areas. If you're a robot developer, you have a lot of work on your hands. You have to, have working perception, navigation, path planning. You have to worry about safety. You have to develop your own fleet manager. So there's a lot of things that are on your plate. On the other hand, when you get to, from the point of view of an end user, you've been running, these warehouses for far longer than there's been robots for this application. So there's a lot of enterprise systems that need to be leveraged, not just like your classic warehouse management system, but you need to manage people, you need to manage the building. And I think, although this is very specific to logistics, you'll find that there's equivalent systems in many other of those industry verticals. So eventually, making those, the top and the bottom match, it becomes really hard, and that's where InOrbit can help. So we can manage the integration, we can manage the different robots, and essentially create a single pane of glass for all your operations. So today we're talking about missions, and that's a key part of both operations and orchestration. And as Jeff mentioned, you'll hear these words multiple times today. The first one is definition. So you need to be able to define a mission in a way that's not specific to any one robot. So for example, if there are key areas that we call waypoints in your facility, that's probably something that every robot, no matter what it does, needs to know about. So you'll see more of that in a minute. Then there's the execution, right? So what good is a mission if you're not running it? And you need to know, as the robots are performing their tasks, their mission, their tasks are parts of a mission. How do you know if they're doing the right thing? And then ultimately, you need to be able to look back and understand what's working, what isn't, what needs attention. So at that point, it's all about metrics and performance and being able to drill down. I think with that, I'm going to pass it over to John, who's going to go into a little bit more details about missions.
Thanks, Florian. Jeff, I think I need you to make me the presenter, please. All right. Okay, thanks everybody for joining today. And as Florian said, we're going to talk a little bit more about missions. First, I want to introduce you to InOrbit. This is InOrbit's executive dashboard. It provides a high-level overview of deployments across the globe. As Florian said, robot agnostic and industry agnostic, but something to provide an executive an understanding of, how are my robots performing wherever they are with high-level KPIs that can draw attention to where it's needed to be. One of these locations is the InOrbit robot space. So let's take a closer look at that. So the robot space is our concept store. You can see Florian down here, and right now he's in the middle. Hi, Florian. This space is where we work with our customers and our partners to demonstrate robot behaviors, where we can define missions, execute them, and then go and analyze the performance as we work with our customers to optimize their operations. So let's take a look at this from an operator's perspective. At InOrbit, we can make it easy for an operator to see a space and to understand where the robots are within that space. So here you can see our restocker robot, some other robots in the space, as well as smart infrastructure like cameras or a door. You can also see operational aspects of the space, like for instance, this zone in the middle that's highlighted, which is a single occupancy zone that only one robot is allowed to be in at a time. Now also, this obviously isn't how the robots see the space. So we can switch to that and also see the robot's perspective, built from its map that it's running on it, so that it knows where it is within the space and can navigate using all the normal robot navigation and perception. In addition, we can add other important aspects of the space to be easily seen, such as waypoints that Florian was discussing. And this provides an easy way for both the robot and for the operator to have a full understanding of the space, and allows these different layers of a location to be easily observed and enabled or disabled. Okay, so let's step into missions. Here you can see the missions that are happening in this space over time, with very actionable insights for them, such as their success rate, average distance driven, or the number of incidents happening per mission. And most importantly, you can drill down into different aspects of those missions, such as perhaps the different hardware models and which ones are performing better or worse than others. All of this is just, at your fingertips as an operator who's looking to improve the operations of their facility. Because ultimately, all of our customers who are using robots are using those robots in order to accomplish something. And so we want to be able to measure and help them measure whether they're achieving those accomplishments, whether their operations are improving based on their investment in their robots. And then obviously you can drill down into other things, like we may want to only look at completed missions and get in some insights into those, or perhaps even drill down into a specific robot. And so here we're looking at our restocker and the work that it's been doing within robot space. Let's come down and look at one of these missions. And this is where we get into what is a mission. So a mission for an AMR and within InOrbit is a sequence of actions, or what we call steps. So steps could be anything like interact with smart infrastructure within a space, or visit a waypoint. Steps can even include expressions that are evaluated based on perhaps the status of some other aspect within the space, a different robot, waiting on an action from a user, such as after picking or restocking has been completed, or even an external system telling the robot what its next step ought to be. So now let's go to a little bit of a simpler mission, and we will execute it and see how InOrbit can help a robot go about its tasks. So here's a simple mission that's going to, where an operator needs to send some stock to the front. And so I'm going to come in here and I'm going to select my robot that I want to use for restocking, and I'm going to dispatch it. And I get confirmation that the robot has been dispatched, and we'll switch back, and you can see that now it is interacted with the door and opened it. It's moving through it, and it's working on its way to deliver stock to the front where a different operator would be present to unload it. Now, what if perhaps I'm in a warehouse, and in this warehouse where normally we would be sending stock, and here we can switch over to this view and you can see the robot doing its work. What if in this case, the normal stock location was obstructed for some reason? And instead of the stock needing to go to its normal location, I as an operator know that it needs to go to an alternate location for some period of time. And in that case, I don't want to have to go back to my IT team or to perhaps an engineering team to update the mission. I as an operator know where it needs to go, and I want to be able to make those changes on my own. And so here's we go back to the map and bring up our waypoints. We can see now that this robot is at the location shelf 1010, which is the first shelf on the first row within this facility. But perhaps this is the space that's blocked, and as the robot's leaving now to go back to its starting location, let's see what we can do about moving this waypoint so that the robot can visit a different location. So as an operator, I can easily select this waypoint. I can move it on the map to its new temporary location. I can save that. In this case, moving a waypoint, we need to confirm that it has, that this is really what I want to do. It is. So I'll move that waypoint. I'll now exit my screen and I can come back. And you can see here that the waypoint has been updated within the mission, and I'll dispatch this robot again. And you can see that the robot now is responding to the same mission that I dispatched the first time. But in this case, instead of visiting the original location with the original waypoint, it'll visit the new location that I was able to update as an operator with just some easy point and clicks of the mouse. Now let's go look at what a mission definition looks like a little bit more closely. For instance, if I was a robot developer and instead of needing to update the location temporarily for a mission, maybe I'm defining a mission altogether. And this is typically how you would do that as an engineer or as an IT technician, deploying the robots and defining the missions for the in the first place. This is a JSON document that many of you would be familiar with. And you can see that it'd be very easy to create these types of documents to define the robot behavior, thinking back to those steps that we looked at earlier where the robot had a sequence of steps that could be different things like waiting for a period of time or interacting with other smart infrastructure within a space. So we can switch back and see that now, yes, in fact, the robot did visit the new location that we asked it to. But perhaps instead of just a temporary update to where that location needs to be, we may at times want to completely update the mission and have the robot perform a different behavior permanently. And so we can switch over to this mission definition document. You can see here, it's the same one that we looked at before. And let's send this robot instead to a different shelf. And you can see I've updated the shelf number, and I forgot to stage my command, so I will apply the shelf. I'll apply that update. You can see it was applied successfully. We'll go look at the mission again, and you can see that the mission has updated, so it's now the new shelf location that I gave it. And again, we'll dispatch the same robot. And you can see that it's opened the door, and we'll head to the new location that we gave it. Very simple way to update the configuration of a mission just through a simple CLI and JSON or YAML documents that we're all familiar with. Okay. And so this is InOrbit missions and how we can work with both end users to help them define, execute, and analyze the behavior of robots within their operation and optimize those. In some cases, you may even have very advanced end users that have many different types of robots. In those cases, these same tools could be used to orchestrate the behavior of multiple robots operating within the same space and providing very easy observability of where those robots are, what they're doing, and their performance. Okay, Florian, I think it's back to you.
Wow, that was a lot in just about 10 minutes, John. Great to see all of this functionality and how easy and flexible it is. So I guess maybe just to make sure that everyone understands, who do you see as the primary user of InOrbit missions?
Well, it really, Florian, can be both the end users and the robot developers. For end users, when they make the choice to invest in AMRs and automation, they need to have confidence that they can do an intuitive user interface, equip their operators to define, execute, and analyze the behavior of the robots that they bought with that investment. And so that's really critical. For robot developers, they need to provide the tools for their end users to do exactly that, to define, execute, and analyze behaviors, but that is very rarely a core competency for a robot developer. They typically have really constrained engineering capacities, and they want to focus as much of that engineering capacity as they can on making the best robot that they can make with the best navigation, or maybe a novel application that requires a lot of it like creative problem solving. Whereas dispatching and managing fleets of robots is a pretty common problem that we can provide a single solution that they can just incorporate and leverage and provide that value to their customers without such a significant engineering allocation.
So I can totally see that for, let's say, a new robotics company. They're going from their first pilots and they're starting to scale. And now all of these like fleet management and other functionalities are being asked for by their customers. But if you're, let's say, a larger road developer, maybe you already have a fleet manager. Does that mean that it's incompatible with InOrbit missions?
That's a great question. And many of the more mature robot developers do in fact have fleet managers, and some of them are quite well developed. In those cases, InOrbit can work with those fleet managers to extend them if there's additional capabilities that InOrbit has developed that the fleet manager is missing, or perhaps to provide observability and analytics across a number of locations, whereas typically a fleet manager is deployed on premise into a single location. In either case, InOrbit can work with those fleet managers delivered by robot developers to bring additional capabilities or to help them operate more efficiently within a given facility.
So you mentioned end users at the beginning. An end user could be any company that's applying robots to their operations in all those different industries that I was talking about before. Do you have any particular examples of end users and their challenges in integrating robots into their operations?
Oh, there's so many stories. Anybody around robots has so many stories about the challenges of actually getting a robot running in production. Some of the most common ones that we've run into are perhaps you're a warehouse, a 3PL, or a manufacturing facility, something like that, and you've had forklifts in your facilities forever to facilitate moving product around, and now you're introducing AMRs. Well, the challenge is the AMRs don't know where the forklift is, and if the forklift driver is distracted, you can very often end up with collisions. And as we always say, when an AMR and a forklift get into a fight, the forklift always wins. Those types of conditions are really common, and InOrbit can bring solutions together to help solve some of those situations.
Fantastic. And so I think that gets to the point of, what if you have different robots, they're from different vendors, you have your own warehouse management system or ERP or inventory management, depending on what type of facility you're operating. Even if each of those has its own like fleet manager, making them all work together has been like a major challenge. So not just with manually operated vehicles, as you were describing, but different robots. They're each smart in their own right, but together it seems like the collective IQ of the robots goes down. So can you share a little bit more about what InOrbit can do to help there?
Yeah, absolutely. So when you have an advanced end user that's deployed multiple types of automation into their facilities, you end up with a real challenge with your operators, where they have what I call the swivel chair problem. For every different system that they're trying to optimize or operate, they have to log into a different application in order to define those behaviors. If there's a WMS present, then each one of those FMSs has to have its own unique integration into the WMS, which is expensive, both in terms of initial deployment and execution, but also in maintenance. InOrbit can provide a single pane of glass that has observability across all of those different solutions. So not only helping avoid kind of legacy infrastructure like a forklift, but also helping smart autonomous robots understand where each other are. And just like we referred to at the very beginning about the single occupancy zone around this smart door that we have at Robot Space, there are occupancy requirements or no-go zones even, or directional zones for which way it's okay for a robot to pass, and where it can provide all of these things within a facility that are then common across every different robot that has been deployed in that facility, so that there's one location to manage your facility's configuration for robots and optimize the behaviors, and then importantly, analyze the performance of each of those robots against each other, against operational updates. If you introduce a new process and you want to see how well that process is improving your operations, all of those things can be discovered and analyzed through mission analytics.
Wow, this is fantastic. I know we're about to run out of time, so Jeff, do we have time for one question from the audience, maybe?
Yeah, I think so. I would love to actually, here's a question a bit more on analytics. And I know actually, John, I've heard you tell me stories about, and I'm sure it wasn't you or your friends, but the realities of how trying to pull insights from the business driving insights from those specific robot analytics in your systems, and how people, in reality, how operators are often managing that in production environments. Can you talk a bit more about that power of comparative analytics and how to pull the insights from that?
Yeah, absolutely. And this is something that I know firsthand, because I've experienced this pain when I was with a robot developer years ago. Oftentimes, robots generate a tremendous amount of data. Managing that data is a challenging problem, and often you get a very engineering-focused solution to that problem of bringing that data up to the surface, and it can be hard for an operations team to take advantage of. And so what you end up with is operations teams are analyzing performance using legacy tools, like even a spreadsheet. With mission analytics, what we want to do is bring that rich data that is there with the robots and make it really easy for an operations person, somebody who's looking at the performance of the fleet day in and day out, to be able to understand what's working well and what's not without needing a degree in engineering.
Amazing. That's great. I think with that, unfortunately, we are out of time. I just want to say thank you so much to everyone for joining us today. We had a great time. I think that we covered a lot of information. If you have questions, please, of course, reach out to us, team@inorbit.ai, or follow up. There's more information on our website, inorbit.ai/missions, of course. Thank you to John, thank you to Florian, and thank you for attending. We'll catch you all next time. Have a great day.
Thanks all.